I was asked to speak about the materials perspective by Volvo, and this is really kind of one of my sweet spots and an area that's close to my heart. And so I wanted to challenge you as an audience to sort of think about material supply and recycling. I think when we look at material supply, the perspective seems to really focus more on material selection. But I think just to challenge you to think also about, well, what happens when we select those materials for a particular job? When we think about the transport of those materials, the selection of those materials can have certain impacts on how they are transported to a site. Use and implementation of the materials on site also are affected by the types of materials that are selected. And then the quality and life expectancy of the materials also translate into that. Again, going back to the slide, if you remember, of the CCC's mandate that shows the circular chain, the life cycle chain, if you will, really, when you think about materials selection, all of those factors also come into play here as well. And so what I'm going to do is go through each of these areas and hopefully highlight some things that perhaps you maybe reinforce some things that you're familiar with, but perhaps also highlight some things that you may not be familiar with as well. So when we think about materials selection, obviously there's the emissions that might come from the manufacturing of the materials, whether they're virgin materials or recycling and processing of materials. But also, I think many of us, at least in my role when I was consulting and did site civil work, we sort of think about the materials when we really source them from wherever they're warehoused at. But there's also the aspect of the point of the manufacturer to the point of supply that also need to be considered. And then there are other attributes that perhaps are a little bit more esoteric, but can have or influence the emissions profile as well. Factors such as the density of the materials, the shape and size of those materials, which then affect the quantity of those materials that can be transported per load, as well as on-site versus off-site assembly considerations that also come into play. So when we think about that, I asked the question here on this slide, do recycled materials always make sense? And I think that there is a perspective that recycling is always good no matter what. And a point here with this slide, if you look at this highlights the use of recycled glass and the different possible endpoints for glass, from reusing glass to a container setup all the way down to an aggregate material for construction purposes. And so in this particular scenario, if one wants to use crushed glass as an aggregate for roadbed for construction, for example, this suggests that using the glass for aggregate, it does reuse the glass, but it doesn't necessarily reduce emissions. So this is a perspective where recycled materials may make sense or may not, and it really is on a site-specific basis. And so that's part of where I'm going with my remarks today, is that really when it comes down to reduction of emissions, we really have to think about this on a per project, a per site basis, because using national averages and other numbers like that when we talk about metrics, for example, really do little to help us understand what happens from a total emissions footprint standpoint. And really where the rubber meets the road is when we talk about things on a project level basis. So this is just an example just to familiarize you with where some of these recycled materials could come from, and they're not always spent construction materials from a demo project. Certainly we can get concrete that way. EREF is, for example, funding some work to not only use construction as crushed aggregate for roadbed construction, but also we've advanced some science through some various universities to try to repolymerize that spent concrete so that it can be used for structural concrete again, which is something that's not typically been done, if at all. Other sources include fly ash from the utilities industry, and specifically coal-fired power plants are another source of material that can be used for gypsum wallboard as well as concrete. Other materials such as glass, I've mentioned, wood, and other metals, of course, can be used, and those can come from many different kinds of industries. And then you've got some one-off materials that can be used successfully as construction materials in certain settings, such as carpet or shredded tires, for example. This really tells the story when we talk about the emissions from the manufacturing of the materials. And you can see really one of the aha moments for me is looking at aluminum. You've got aluminum, it's off the charts, 9,900 kilograms of CO2 per ton of material with primary production. When you look at secondary production, which is the use of recycled aluminum, look at the factor of difference there, it's huge. And so that suggests that certainly there are situations where using recycled materials is almost a no-brainer from a material standpoint. Then when you go down the graph, looking at steel as well as concrete, you see that things get a little bit more fuzzy. Steel looks pretty good. Concrete has historically not been a big player from a structural concrete to a structural concrete reuse scenario. But when you look at wood, for example, the data is a bit more variable. And I would say that if you were to look at other data sets, this is from an EPA data set, you could find very different numbers here. So not only do we see some fuzziness in the numbers here, but there are other data sets that can show different numbers as well. So that's another point, is that the data we're looking at, we want to make sure that that is, again, as specific as it can be and as accurate as it can be, and that there are some challenges there in certain areas. Just as showing this a different way, these are actually the avoided emissions for the reuse of certain materials, and as you saw from the previous slide, aluminum really stands out with more of marginal avoided emissions when it comes to asphalt and concrete. Certainly if we're able to repolymerize concrete and reuse it as a structural material, we would conceivably see the avoided emissions for concrete, for example, rise dramatically. So now let's shift modes. We talked about material production. Let's talk about material transport. The mode of transport has a huge impact on the emissions footprint for a particular project. In particular, trucking, over-the-road hauling of materials is an enormous emitter of greenhouse gas emissions. And so, kind of getting to Margaret's talk back here, look at rail. I mean, when you talk about shipping materials by rail, huge decrease in emissions. Shipping as well. Obviously, we don't have waterways, navigable waterways everywhere in the United States or elsewhere, but certainly where there's an opportunity to transport via ship or rail, you can greatly reduce project emissions. Once the materials are on site, then you have further challenges when it comes to emissions. So in particular, I'd like to emphasize the complexity of installation. If you have a project developer that wants a highly architectural facility or something like that, and they can be very beautiful, but at the same time, the complexity of the construction can also create more challenges. It can be more difficult to actually initiate and complete that project, which can result in some lower efficiencies, and then that turns into higher emissions as well. You just spend more time operating equipment to get these materials up and built. And that can also affect the types of equipment needed as well. Certainly with a more complex site, you end up with challenges on the deconstruct side as well, because it can be more challenging to also deconstruct those projects at the end of life. So those are certainly things to consider. And when you look at the differences, going back to the material selection, these are the emissions based on the implementation of specific materials on a site. And you can see concrete, by and large, has a larger emissions footprint if that's being used as the material of preference versus steel or wood. And so the material selection can certainly impact the emissions footprint as well. Lastly, the last factor here is really material longevity. When we think about using a certain kind of material, say we want to use wood, for example, well, how long will that project, how long will that building, for example, last with that particular kind of material? If we can have a project last 100 years versus 50, certainly that can reduce emissions overall as well, versus a material that may have half the lifetime where you're having to replace that material over time. So when we think about emissions for materials, it's not just at the end of project turnkey. We've just unlocked the doors, they're open, grand opening. We're really thinking about what happens with that, with the use of that material through the use of that building all the way through the end and the deconstruct phase as well. So that also has implications. And certainly, at least I know in my experience as a site civil engineer, work quality is a huge factor. We've worked with contractors that we've had to come back and regrade the site, sometimes 2-3 times, not the entire site, but large portions of that. Think about the emissions footprint when you have poor quality work done. Coming back, redoing things, which doesn't speak well for reducing your emissions footprint. Okay, so let me wrap this up just by highlighting a specific example and just noting the complexity of how emissions might work. Let's just assume we have a 200-ton material project that's here in Las Vegas. We have material options for virgin wood sourced out of Eugene, Oregon, or recycled steel that might be sourced out of Shanghai, China. And for those of you who are not familiar with this, China is now the largest provider of steel. They provide 51% of the world's global steel supply. So when we look at this on a numbers basis, one thing I think that is interesting in this example is that certainly the wood, which is virgin wood, has a lower emissions footprint for production than recycled steel initially, right? So we're transporting that 871 miles from Oregon. You're going to have transport emissions of 35.2 tons of CO2, which ultimately gets us on site at 82.4 total tons of CO2 emissions for wood. For recycled steel, we're going to boat that just about 6,500 miles from China to LA. Then it's going to be transported from LA to Vegas, which is going to collectively bring us another 22.4 tons of emissions. So you can see use of the recycled steel here actually has a larger emissions footprint getting to site than the virgin wood material. Again, highlighting recycled materials may or may not be the best choice depending on the dynamics of your specific profile. I'm not trying to say we should use recycled materials. I'm just suggesting that we need to be thoughtful about how we initiate projects and how we select materials. Now, let's bring in the material longevity aspect of things, though. If wood, for example, 50% of the wood is replaced over the lifetime of that particular project, now you have total emissions equaling that of steel. So again, this is not something that we get done with the project, we walk away from it and pat ourselves on the back and say we've done a great job on emissions. We really have to think about what happens to that site after you're done with the construction and what happens with material replacement and so on. So what does the future hold? When we think about the data and the metrics, I will note that the science isn't all the way in on some of these metrics, and we were talking about this in the cab all the way over, that some of these data metrics, we really need to have more improved metrics on a site-specific basis to be more accurate about computing our greenhouse gas emissions. And the modeling that's being done, certainly they're getting more accurate every day. So I think we'll reach a point where we could accurately and completely quantify greenhouse gas emissions on a per site basis, basically do a full cost accounting of greenhouse gas emissions on a per site basis very well, probably in the next decade or so. Right now, some of the inventory data sets that are used can provide very uncertain numbers, and so that's something to be aware of. Certainly, and I'm excited for the next talk because innovation, I believe, can and will drive the increased use of recycled materials. It can and will drive reduced emissions, and there's a lot going on in that front. So I think the landscape of what the future holds is going to look very different in the next couple of decades. The last point I'll make here really is the interdependency of different industries upon one another. For those of you who are from the US, you are probably aware that a large number of power plants that use coal for their, to burn coal for electricity are now being transitioned over to natural gas. You think, well, why do I care about that? What does that matter for the construction industry? Well, it matters a lot because the fly ash that's coming out of those power plants are used, and they're a primary ingredient in concrete manufacturing. There are already local shortages in the US of fly ash for construction materials. Some of the fly ash is now being imported from China. We expect, and I'm familiar with one of the larger utilities in the southeast called Duke Energy, are closing 26 coal-fired power plants over the next 15 years, which is going to, all of that fly ash then is going to go away. So we expect over the next 2 decades to see some major shortages in fly ash, with us now becoming an importer of fly ash rather than an exporter of fly ash. And that has some significant implications for the construction industry as a whole. We expect pricing to significantly go up. So that's an example of where what's happening in other industries can greatly affect and can significantly affect what's happening in the construction industry.